Now, there are two types of reaction mechanism. One is your concerted mechanism. And the second is your non-concerted mechanism. We can say that. Non-concerted mechanism. So what is concerted mechanism? You write it down. Reaction mechanism in which the breaking and making of bonds takes place simultaneously. Without the formation of any intermediate. It is called a concerted mechanism. The reaction mechanism in which the breaking and making of bonds takes place simultaneously without the formation of any intermediate, it is called a concerted mechanism. Breaking of bond takes place and the making of also bond takes place simultaneously. Got it? Both takes place simultaneously. Got it? Without the formation of any intermediate, means directly reagent reacts with the substrate molecule to give rise to a product. So that is called as a concerted mechanism. Again I repeat, reaction mechanism in which the breaking and making of bonds takes place simultaneously without the formation of any intermediate, it is called concerted mechanism. It is called as concerted mechanism. Now next is non-concerted mechanism. A mechanism which proceeds to the formation of intermediates. A reaction which proceeds through the formation of intermediates before the products get formed is called a non-concerted mechanism. A mechanism which proceeds through the formation of intermediates before the products get formed is called a non-concerted mechanism. Means here an intermediate product will be formed. Directly you will not get the product. Attacking reagent will react with the substrate molecule to give rise to an intermediate product, and that gives rise to products. That is primary product and secondary product, you will be getting it. That is called non-concerted mechanism. Alright, now we will come to the different, the effects which is being produced by the reaction mechanism. When the reaction mechanism is taking place, so many effects are there. Got it? Some are permanent effects, some are temporary effect are being produced. So the first one is your inductive effect, otherwise called as I effect. Got it? Under effect, the first one is your inductive effect, otherwise known as capital I effect. We can say that inductive effect or I effect. We can say that. So the permanent displacement, write down what is inductive effect. The permanent displacement of the shared electron pairs. The permanent displacement of the shared electron pairs in a carbon chain towards the more electronegative group is known as the inductive effect. The permanent displacement of the shared electron pairs in a carbon chain towards the more electronegative group is known as the inductive effect. We can say that. Is known as I effect. That is the permanent displacement. So first of all, let me tell you, inductive effect is a permanent effect. It's not a temporary effect, it's a permanent effect. And the displacement of electrons takes place. Transfer of electron does not take place. Displacement of electrons. There's a difference between transfer and displacement. This transfer means completely an electron is getting transferred from one atom to another atom. It goes from one atom to another atom. That is called transfer. Alright, like in case of ionic bond, it takes place. One it forms a cation, another it forms an anion. The one which has got deficiency after transfer, the one which has got deficiency, positive charge, that is a cation. And after transfer, the one which has got excess of electron, that is negatively charged, is known as the one which has got excess of electron is negatively charged, we can say. Clear? So here that thing does not take place. Transfer is not taking place. Displacement of electrons means electrons is pulled towards a particular electronegative species. It is being pulled. The electronegative species pulls electrons towards itself. We can say that. That is being pulled. So permanent displacement of the shared electron pairs, electron which is being shared between the two combining atoms, it is being pulled. in a carbon change towards a more electronegative group? Definitely. Suppose we are having CH3Cl. So what you will find is that here CH3Cl. So Cl is more electronegative. It is going to pull the pair of electrons towards itself, due to which this becomes negatively charged and this becomes positively charged permanently. It is being pulled, it is being shared, it is not transferred. Got it? So hence this is called as inductive effect. Got it? This is known as. So inductive effect is of two types. Again, if we are having minus I effect and we are having a plus I effect. Now what is minus I effect? Write down. If a group is more electronegative than the hydrogen, first is minus I am saying minus I effect. If a group is more electronegative than hydrogen, then the group withdraws electrons from the carbon chain. Then the group withdraws electrons from the carbon chain. Then the group withdraws electrons from the carbon chain towards itself as compared to hydrogen. Towards itself, it is said to have minus I effect. It is known as minus I effect. Alright, if a group is more electronegative than hydrogen, then it will withdraw electrons from the carbon chains towards itself. That is called minus I effect. Alright, so this one, it will withdraw electrons from the carbon atom. So it is minus I effect. We can say that. Now, plus I, opposite of that. Got it? So what I will say, if a group attached to the carbon is less electronegative, if a group attached to the carbon is less electronegative than hydrogen, if a group attached to the carbon is less electronegative than hydrogen, it donates electrons to the carbon atoms. It donates electrons to the carbon atom. It is said to have plus I effect. It donates electrons to the carbon atom. It is said to have plus I effect. We can say that. It is said to have plus I effect. So if this group which is attached to the carbon is less electronegative than hydrogen, alright, it's less electronegative than hydrogen, then it will, instead of what you can say, pulling the electrons towards itself, it will donate electron to the carbon atom. It is going to donate electron to the carbon atom. Then that is said to have plus I effect. We can say that. That is called as plus I effect. Clear? Achha. Now next is I said you already that if you see the characteristics of the inductive effect, there is no virtual displacement of electrons in a carbon-hydrogen bond. Alright, there is no transfer of electrons. Alright, it is because the electronegativities of both the atoms are nearly the same. Carbon and hydrogen electronegativity both are same nearly. Carbon the electronegativity is 2.5 and hydrogen is 2.1. It is nearly same. So hence CH bond is nearly covalent in nature. 100%, almost covalent. We can say that. So hence there is virtual no displacement of electrons in a carbon-hydrogen bond. Inductive effect always takes place between the carbon atom and an electronegative atom or group. We can say that. That is sharing only a pair of electrons. We can say that. So in other words, in short I can say inductive effect involves only single bond present in it. It takes place only in case of single bond, not in double bond, not in multiple bond. Alright, again I repeat, inductive effect always takes place between carbon atom and an electronegative atom or group sharing only a pair of electrons, only one pair of electrons. So hence it is taking place in single bond. Alright, inductive effect is permanent, already I said you, from the definition itself we can say, and is irreversible in nature. It is permanent effect. The electron displacement progressively decreases along the carbon chain as the distance from the carbon atom, that is attached to the substituent, increases. Alright, that means I mean to say that here, that is so many carbon atoms is there. So this chlorine, now listen carefully, this chlorine is going to pull electrons first. It is going to pull electrons on this carbon. So it becomes positive. Consequently, this carbon pulls electron from this carbon. Consequently, this carbon pulls electron from this particular carbon. So it is being estimated that, it is being seen that beyond the third carbon atom, the inductive effect becomes nil or negligible. Why? Because the electron cloud of this electronegative atom or group has no influence beyond third carbon atom. Alright, the electron cloud of this more electronegative atom, whichever electronegative atom or group is attached to the carbon atom, whichever. Alright, it has got an electron cloud. It has got an influence over this carbon atom. So it is being estimated, it is being seen that beyond third carbon atom, this influence of the electron cloud upon the carbon atom becomes nil or negligible. We can say that. So hence I said that as the number of carbon atom increases from the electronegative atom or group, then progressively the inductive effect also decreases. So as the distance of from the electronic group increases, as the number of carbon atom increases, remember it, the inductive effect also decreases, so to say. Alright, so this is very important point, you need to remember it. So the displaced electron do not leave their orbitals. I've said you already that no transfer takes place. It does not leave, only the orbital is deformed a bit, the shape changes, the shape is changing, and this causes polarization. Means if the orbital is this, after displacement the orbital becomes this, we can say that. So this is becoming negative and this is becoming positive. Initially the charges is equally distributed. Alright, so after the inductive effect, the shape becomes this, it gets deformed. The negative charges accumulates at a point and then there is a deficiency of electrons. This takes place in case of inductive effect, so to say. Alright, there is no transfer of electrons, only there is a displacement and hence it causes polarization. See, it's polarization, one is negative, another is positive. So the polarization takes place. So different groups causes polarity to different extents. Definitely, the one which is more electronegative will be more polarized. The one which is less electronegative in nature will be less polarized. We can say that. Got it? So NO2 is more polarized than Cn minus. Rather, Cn minus is more polarized than SO3H. SO3H is more polarized than COH, which is more polarized than F, which is more polarized than Cl, which is more polarized than Br. You will say that how did I come to know? Electronegativity. Very simple. You have studied electronegativity. Fluorine, chlorine, bromine, iodine. Electronegativity decreases down the group. Alright, similarly, nitrogen, sulfur, you know the electronegativity. Alright, nitrogen is less electronegative compared to oxygen. We can say that. So in this way, all this is nothing but about the electronegativity. Alright, so in this way, that is tertiary alkyl group undergoes positive inductive effect. So 3 degree, that is what you can say, carbon atom is more inductive than 2 degree, is more inductive than 1 degree, is more inductive than methyl, is more inductive than what you can say, hydrogen. Alright, remember it what I said, that is 3 degree. 3 degree means what? This is your 3 degree carbon atom. It is attached to 3 alkyl groups. This is your 3 degree carbon atom, which is more inductive than 2 degree. Let me rub this on. It is more inductive than 2 degree. This is your 2 degree, which is more inductive than 1 degree. This is your 1 degree. This is 1 degree, which is more than methyl, which is further more than hydrogen. We can say that. Alright, which is much more than hydrogen. This is your positive plus I effect. This is about your plus I effect I was talking to you. Got it? So in this way. So this is about your inductive effect. The applications of the inductive effect, if you see, then CH3Cl is more reactive than CH4 due to the presence of inductive effect of Cl. Alright, if you ask me the reactivity of methane and methyl chloride, which is more reactive? Methyl chloride. Why? Because in methane, all carbonate is attached to all same atoms, that is hydrogen atoms. But in case of methyl chloride, carbonate is attached to 3 hydrogen and 1 chlorine. So chlorine is more electronegative than carbon. So it pulls electrons towards itself. So CH3Cl is more reactive than CH4. So the presence of different groups, different electronegativity makes it more inductive, makes it more reactive. We can say that. What I said, presence of different groups, carbon, chlorine, hydrogen, different groups, makes it more reactive because the electronegativity differs for that particular purpose. Like the strength of an acid depends upon the tendency to give up a proton. We can say that when the acid is dissolved in water, so it how it loses H plus ions readily. The acid which loses H plus ions more readily is more stronger in nature. We can say that, and that it depends upon the inductive effect. That it depends upon the inductive effect. We can say that it can be explained by the help of inductive effect. Now all these things you'll be learning in the higher classes about it. Alright, so any group or atom showing plus I effect decreases the acidic strength. Alright, like suppose with CH3COH if chlorine is attached. Alright, let me take these two compounds, CH3COOH and CH2Cl COOH. Now chlorine is minus I effect. It will pull the what you can say hydrogen, what you can say the electrons more readily towards itself. So H plus ion will be more readily released from here than here. Chlorine will pull the electrons more readily towards itself from oxygen, due to which the cleavage of H plus ion takes place readily. The cleavage of H plus ion means H plus ion is more readily released from here, that is chloroacetic acid, than acetic acid. Got it? For that particular purpose, this is more reactive than this. Now, instead of chlorine, if I put fluorine, suppose here chlorine and here that is fluorine, if I put CH2F. Now, this is more reactive than this. Why? Because fluorine is more electronegative than chlorine. So, fluorine is going to pull more readily the H plus ion towards itself than chlorine. Because fluorine is more electronegative than chlorine. So, the idea of electronegativity should be very clear to you. Alright, before you study this particular chapter. For that reason, I said earlier, when I was teaching, that is bonding, then periodic, then atomic structure, I told you that these three chapters are very, very important for your organic chemistry. This is a concept of organic chemistry. We can say that you require the concept of organic chemistry. You require the concept of this in organic chemistry. Okay, so fine, you need to understand that. So base strength may be defined as the tendency to donate an electron pair. The base strength. Acid strength means the tendency to give up the electron pair, and the base strength is the tendency to what you can say, that is donate an electron pair. Clear? So the base strength. In this way, the base strength and the acidic strength can be explained on the basis of inductive effect. We can say that. The inductive effect leads to polarization of bonds. Got it? Thus, the dipole moment increases with the increase in the inductive effect in the group. The dipole moment. Alright. Here, the dipole moment of this fluoroacetic acid is more than chloroacetic acid. Why? Because fluorine is more electronegative than chlorine. So, this is having higher dipole moment than this. Got it? Again, chloroacetic acid is more acidic than acetic acid. Why? Because due to the presence of electronegative group, that is chlorine. So hence the dipole moment also depends upon the inductive. It depends upon the different atoms which is attached to it. Got it? So in this way, this is about your inductive effect, so to say. We can say that. So now next we'll come to, that is nothing but is your, the next effect is your electromeric effect. We can say that. The next effect is your electromeric effect. Now, in electromeric effect, let me rub it first. Okay, so electromeric effect or E effect, we can say that, capital E. Electromeric effect or E effect, we can say that. Electromeric effect. What is that electromeric effect? It involves the complete transfer of electrons. It involves the complete transfer of electrons. That is complete. That is what I can say. It involves a complete transfer of electrons from one atom to another atom. Alright, from one atom to the another atom. That is called. So, of a multiple bond, double and triple bond to one of the bonded atoms, we can say that. Clear? So here, first of all, complete transfer, no, that is what I should say. In the previous one, inductive effect, you studied that there was polarization was there. The complete transfer of electron was not there, that the electrons was being pulled, it was being shared in this way. So, but here the complete transfer of electrons is taking place. And here it is not taking place in single bond, it is taking place in a multiple bond. More importantly, the word I have not used. So, this entire transfer of electrons is taking place in the presence of an attacking reagent. So, hence it is a temporary effect. Electromeric effect is a temporary effect because it takes place in presence of attacking reagent only. If you remove the attacking reagent from the site of the reaction, then this particular effect ceases. It no more takes place. It ceases. We can say that. Got it? So it's a temporary effect. It takes place in multiple bond. Here it involves a complete transfer of electrons. We can say that. Again I repeat. It involves a complete transfer of electrons of a multiple bond, that is double or triple bond, to one of the bonded atoms, usually more electronegative, in presence of an attacking reagent is called electromeric effect. In presence of an attacking reagent is called electromeric effect. It involves a complete transfer of electrons of a multiple bond, that is double or triple bond, to one of the bonded atoms. What you can say, bonded atom should be, one of the bonded atoms, it should be highly electronegative, we can say that. Clear? So, in presence of an attacking reagent, that's a very important words, in presence of attacking reagent is called E effect. That is called electromeric effect. And electromeric effect takes place in presence of attacking reagent only. As soon as attacking reagent is removed from the site of the reaction, this effect ceases. It no more takes place. We can say that. So hence it is a temporary effect. Attacking, what you can say, electromagnetic effect. Electromagnetic effect is also of two types. We can say it is also of two types: plus E effect and minus E effect. Plus E and minus E effect. Just like inductive effect was plus I and minus I, here is also it is plus E and minus E. Now, what is plus E effect and what is minus E effect? We can say that. So, the first is that the plus E effect, we will say, if the electrons of the pi bond are transferred to the atom of the double bond, you can write it down. If the electrons of the pi bond are transferred to that atom of the double bond, atom of the double bond to which the reagent gets finally attached, that is towards the attacking reagent. You can remember this way, that is towards the attacking reagent, is called plus A effect. When the transfer of electron takes place towards the attacking reagent, it is called plus A effect. Again I repeat, if the electrons of the pi bond are transferred to that atom of the double bond to which the reagent gets finally attached, that is towards the attacking reagent, is called plus E effect. We can say that. That is, I should say, plus E effect in this way. It takes place in multiple bond. So it is H plus. So towards the attacking reagent. Towards. We can say that. Clear? So here the 4 bonds is completed. You can see the 4 bonds of the carbon atom is completed. 1, 2, 3, 4. The 4 bonds. And this is the efficiency. This is positively charged. We can say in this way. This is called plus effect towards the attacking reagent. Now, if the now we will come to the minus effect. So it is away from the attacking reagent. To remember it easily, the transfer of electrons is taking place. So if on the other hand, the electrons of the double bond are transferred to an atom of the double bond other than the one to which the reagent gets finally attached, that is away from the attacking reagent, the effect is called minus E effect. Again I repeat, if on the other hand the electrons of the double bond are transferred to an atom of the double bond other than the one to which the reagent gets attached, finally,